Hello, welcome back. So in previous video I gave you a brief introduction to business statistical analysis, and then we discussed some application of business statistical analysis in different fields of business. We discussed some application of business statistical analysis in finance. We discussed the application of business statistical analysis in marketing operations and management and human resource management. So, after the brief introduction and application of business analysis in different walks of life, now we will start our topic, and we will start with some terminologies which we use in statistics, and then we will discuss that how we can formulate the problem in statistics and how we can analyze the problems. Okay, so we will discuss the basics of statistics. I think if you have basic knowledge of statistics, then maybe it's just a revision for you. But we will continue in future with the more advanced level application of business statistical analysis in the business. To start with, first of all, let's discuss the data. So, what is a data? So, data is anything that we get from other resources, other sources. And data may have different forms. Data can be in the form of video, data can be in form of a text, data can be in form of numbers, and so on. So in statistics, mainly we will be focusing on managing the numbers, and up to some extent we will discuss that how we can translate categorical data into numeric value. But most of the time whenever we perform statistical analysis, we have to convert the data into the numeric form, and then we can perform the analysis. Okay, so the question is, what is statistics and how we can use in real life to solve real life problems. There is a big debate among scholars. Some says that statistics is a science, some says it is an art. But if I borrow the argument from both parties, I can say that the science is art as well as statistics is a art as well as science. So we can see that statistics is an art of science of collecting, presenting, and analyzing the data to answer an investigative questions. Its goal is translating data into knowledge and an understanding of the world around us. In short, statistics is an art and science of learning from the data. So we use statistics to solve real life problems, but to apply the scientific principles of scientific analysis, first step is to understand the problem. So first we understand the problem, and after understanding the problem, we devise a research question, investigative question. For example, my investigation question is, we want to identify the frequency of earthquake in a specific city. Okay, so this is my question, and to answer this question we need to gather some data. And data will the nature of data will be history of previous earthquake in last 100 years. So once I have a data for earthquake in last 100 years, then for me it is easier to analyze the data, and then using some statistical model we can predict the frequency of occurrence of earthquake in a specific city. So the first step in statistics is an art, because we gather data from different resources, we organize the data, we analyze the data, and after data analysis we go for presentation, and then people can use it as a knowledge for their real life usage. Okay, so now here, as I mentioned before, statistical process is a systematic procedure of solving a real life problem. So statistical investigative process involve four components. So the first is understanding the problem. In my previous example, the problem is occurrence of earthquake. are the frequency of earthquake over the time. So this is a problem, and we want to assess the frequency of occurrence of earthquake in a specific city. So my question is, after how many years we can expect an earthquake? So this is my statistical question. So to answer this question, we gather the data. Maybe for data collection, we can use different resources to gather the data. We can use primary data by conducting some interviews, designing some surveys, and also we can fetch some secondary data from the different web sources. And then after we gather the data, then we analyze using some statistical models, and after the analysis we can make prediction, and we can make decision, we can answer to the questions in the stage 2, which is formulation of statistical question. So these are the statistical procedure is a 5-step procedure. We understand the problem, we formulate statistical questions, we collect the data, we analyze the data, and then we interpret and communicate the results to the relevant stakeholders. So what is the reasons for using statistical methods? Okay, so these are the 3 reasons that we have to keep in mind while using statistical model. So the first reason is a design, stating the goal and or our statistical question of interest, and planning how to obtain the data that will address them. Okay, so whenever we use statistical model, so to use the model we require some data, and for generating data or getting data through the observations, through the experimentations, we usually design the experiment, we design the question, we design the questionnaire to ask questions, relevant questions from the audience, and then we use the responses in numerical form to analyze it. The second one is a description. Once we have gathered the data from different resources, we summarize the data, we organize the data, and we identify the different patterns in the data, and then we analyze the data, which is a description. Okay, so after describing the behavior of data, we can add some predictive model to make decision. And the final, once data is organized and summarized, it is in good form, we have good images, good graphs. So, and we have used some statistical models which give us some significance of factors. Some factors might be significant and some factors might not be significant, so we go for the inference. So inference is making decisions and predictions based on the data for answering the statistical questions. So mainly that's the reasons that we start with the designing, description, and inference of the results. Okay, so now we will start with the, I think you are familiar with the population. So the population is a total set of subjects in which we are interested. A sample is a subset of population for whom we have the data oftenly randomly selected. So I will give you an example of population. For example, we have a country A and its population is 22 million. Okay, so we have a population of 22 million people, and I want to know whether they participated in election or not. Some people vote, some people do not vote. So I want to see that how many people participated in the election. Okay, so to answer this question, it is almost impossible to get the responses from 22 million people. So instead, we pick a random sample, we ask questions to the random sample, and on the basis of results from the random sample, we make prediction about the population. Okay, so sample is a subgroup of a population. So usually whenever we design this design surveys, we design studies or experiment, we design the sample as well. So we choose usually we choose the random sample from the population, because analyzing the random sample can give us better idea about the behavior of population. So now based on our discussion and the different phases in evaluation of a specific research question, we can classify statistics into two categories: descriptive statistics and inferential statistics. Descriptive statistics refers to methods for summarizing the collected data, where the data constitute either sample or population. The summaries usually consist of graphs, numbers such as averages and percentage. We use, in addition to the graphs and numbers, we sometimes use numerical summaries of the data as well. For example, in data set, we have two types of measures: measure of center, measure of dispersion. So measure of center means that we calculate the mean, median, and mode, and measure of dispersion means that we compute the standard deviation and variance of the data. In addition to that, we can also use graphs such as bar chart, pie chart, line chart, scatter plot, stem and leaf plot. So there are so many categories of graphs in statistics which can be used to display the data. And the third thing we can use is the use of tables. So sometimes we describe the data using different forms of table. So here is an example. Can you see that how retail stores use descriptive statistics? The answer is because retail stores use point of sale softwares, and every time they are getting data. So the data they gather using point of sale software can be analyzed to understand the behavior of sales. They can easily see that how many products they have as an inventory, how much product are sold today, how many customers visited them, what was their average sales, so they can describe the data using different types of graphs and tables in point of sale softwares. So therefore, retail stores are extensively using descriptive statistics to understand the inventory level, to understand the customer behavior, to understand the items which are high in demand, to understand the items which are are about to expire, so they can track and check the availability of product using point of sale software, and for this they utilize descriptive statistics. And then once they have data, and later on managers can analyze the data to make decisions. For example, if they find the sales is declining for a specific product, then they make some decisions that how they can improve the sales. Okay, so based on the data analysis they make decisions. So from here we can say that statistics can be further subdivided into two categories: descriptive statistics and inferential statistics. Descriptive statistics refers to methods for summarizing the collected data. The summaries usually consist of numbers, graphs, and tables. And in inferential statistics, which refers to method for making decisions or prediction about population based on a data obtained from a sample that population. So we pick a sample from the population, and then on the basis of analysis of the sample we make a prediction about the population. So I will give you another example. So let's say you want to launch a specific brand in a specific city. So in order to understand the behavior of market, in order to understand the interest of the customers, so you choose a sample of people for interview. So you interview them, and after interviewing, maybe you can distribute some questionnaire. They fill the questionnaire, they send it back to you, and after analyzing the questionnaire based on the observations of few people, you may start your business in that specific city, because it is really difficult for you to gather data from everyone within the city. So that's why inferential statistics is a powerful tool in making decisions about the population by analyzing the data of a sample. So usually sample is a chosen randomly, okay, from because okay. So now I will describe the difference between parameter and statistic. So as I mentioned before, when we have a data, we can summarize the data using different methods. For example, graphics, tables, and numerical summaries. Numerical summaries means that we can use mean, median, standard deviation, variance, quartile, first quartile, second quartile, and so on. So if we have a numerical summary of population, then we refer it as a parameter. For example, mean of a population is a parameter. Mode of a population is a parameter. Median of a population is a parameter. Standard deviation of a population is a parameter. So if we pick the numerical summary from the population, we refer it as a parameter. However, if we pick a sample from the population and we take the numerical summary of the sample, and in numerical summary we may pick mean, median, mode, standard deviation, variance. Okay, so if we measure the numerical summary of sample, we refer it as a statistics. Okay, so for sampling, when we pick the sample from the population, so in order to choose a sample from the population, so usually we have to accommodate the randomness. Okay, so selecting the random people from the population may give us better idea about the behavior of population. Okay, so if random sampling avoids the biasness in the data we may face while analyzing the multiple samples we pick from the random. So randomness is also crucial in performing experiments. So sometime in statistics we perform different experiments, we assign random value to the different peoples, we assign random questions to different people, and we check the behavior of different people on different experiments. So most of the marketing studies, they when they want to launch the product, they conduct experiment before launching the product to the market. Okay, so as I mentioned before, we pick sample from the population, we analyze the sample, and after analysis of sample we make prediction about the population. But we may pick more than one sample from the population. If I pick one sample from population, sample A and sample B, so within the sample we may find some variation. For example, I pick a group of students from a class and I measure their height, and you will find that the group of 5 students will have different height. So this is sample A. Then again I pick a second sample B of 5 students and measure their height, and again you will find that there is a difference in height. So if I compare group A with group B, then there will be variation between the group. So within the group we may find some variability, between the group we may find some variability. Okay, so variability may exist within the sample, variability may exist between the samples. So variation within the peoples are different from each other. So not surprisingly, measurement we make on them vary from person to person. Between the sample, just as observations on people vary, so do the results computed from the sample. So margin of error. So let me explain. So margin of errors means that how sample statistics is more closer to the population parameter. I will give you an example. For example, average height of people in country A is 180, and it is population mean is 180. But we pick a sample of let's say 10 people and we measure their height, and the sample average is 175. Okay, so the population average is 180 but the sample average is 175, so the margin of error is 5. Okay, so margin of errors measures how close we expect an estimate to fall the true population parameters, that how much percentage of closeness of sample statistics is to the population parameter. Okay, so in this course we will discuss these 9 topics. So we will start with exploring data with graph and numerical summaries. We will try to understand the relationship between two variables. We will discuss that how we can gather the data, and then we will discuss the probability and how probability is effective in our daily lives. Then we will discuss probability distributions, we will discuss sampling distributions, And in inference statistics, I will introduce you to the confidence interval. We will perform hypothesis testing for a single sample, two samples, and also we will discuss analysis of variance. We will discuss multiple regression, and then we will discuss that how we can apply descriptive and inferential statistics and statistical modeling in business to analyze the business problem. So my next video is relevant to the organizing data, and we will discuss the different softwares uh, and the new fields of data science. So in this course, I will introduce you the art studio. In addition to art studio, I will train you on different other softwares, for example, Google Sheets, and I will also train you how we can create survey forms to gather data from different respondents. And then I will also introduce you to create some dashboards using Google Looker Studio feature of Google Sheets. Thank you.